So good morning students. So in this class we are going to discuss about perfectly inelastic collision. So consider a mass m1 and m2 moves with velocity u1 and u2. So after collision, so that mass m1 and m2 stick together, it moves with common velocity p. So that is perfectly inelastic collision. So after collision, mass m1 and m2 moves with common velocity because it's stick together. So the objects stick together after collision, then move with common velocity, that is perfectly inelastic collision. So if a lorry is moving with certain velocity u2, so I am throwing velocity u1. So I throw some bubble gum or some clay. So it moves with velocity u1. So after collision, it moves with common velocity. So because the clay is stick to the lorry, so the clay and lorry moves with common velocity v. So because mass m1 m2 here stick together, so that momentum before collision, so m1 u1 plus m2 u2, then momentum after collision m1 v1 plus m2 v2. So this is normal case. Here for perfectly inelastic collision, so momentum before collision, so it moves with u1 and u2, so m1 u1 plus m2 u2. So after collision, so that m1 is stick to m2, so it moves with common velocity, so m1 plus m2 times v. So from this we can find what is the velocity, that is the common velocity after collision. So v is equal to, so that m1 plus m2 is goes to denominator, so v is equal to m1 u1 plus m2 u2 divided by m1 plus m2. So the same case, so if it is a bullet, so a bullet is moving with certain velocity u1, here again some other material, so it moves with certain velocity, so it's shooting. So after it's hitting, so the bullet and board moves with common velocity v. So it's another example for that perfectly inelastic collision. So what is the loss of kinetic energy in perfect inelastic collision? So in elastic collision, kinetic energy before collision and after collision is equal, but in inelastic collision, kinetic energy before and after collision is not equal. So there should be a loss of kinetic energy. Here the bullet moves with certain velocity, then the hard board is at rest or it's moving, so whatever it may be. So after collision it moves with velocity, but so there is a loss of kinetic energy. The loss of kinetic energy is dissipated as heat or sound or some other cases. So the bullet go and hit, it creates some sound, so it vibration or it creates some fire, so it creates some heat. There is a loss of kinetic energy in perfect inelastic collision. So kinetic energy before collision, that's half mv square, so half m1 u1 square plus half m2 u2 square. Then after collision, so kinetic energy after collision, so kinetic energy initial then final, this after collision, this before collision, after collision, so half m1 plus m2 v square, because after collision it moves with common velocity, so that velocity v, so m1 plus m2 times v square. So there is a loss of kinetic energy, so there is a loss, so loss would be, we need to find, so before collision minus after collision, that is equal to loss of kinetic energy. So there is a loss, so kinetic energy initial minus final is equal to delta q. So just substitute, so half m1 u1 square plus half m2 u2 square minus half m1 plus m2 v square. So we know that common velocity v is equal to m1 u1 plus m2 u2 by m1 plus m2. So if we substitute here that a, this is b, so it's whole square. So using the formula a plus b whole square equal to a square plus b square plus 2ab. Here also denominator a square plus b square plus 2ab. If we expand and rearrange, finally you will get delta q equal to 1 by 2 m1 m2 by m1 plus m2 times u1 minus u2. So this is the final expression. So in this class we have discussed that perfect inelastic collision. We have find the common velocity, that v is equal to m1 u1 plus m2 u2 by m1 plus m2. Then what is the loss of kinetic energy in perfect inelastic collision? Just delta q equal to 1 by 2 m1 m2 by m1 plus m2 times u1 minus u2 whole square. So okay students.